Our next speaker is Keith Smith. Keith loves tinkering with the very obscure parts of JavaScript and authorization and authentication standards. He spends more time tinkering with automation than the time saved from said automations. We can relate. He currently works at Koali, building a low/no code platform built for higher education. Please welcome to the stage Keith Smith.
All right. I know some of you may have been expecting Ethan Garfalo, and I really wish I would have been in the audience listening to his talk, but I get to talk to you today about server-sent events. So this was something that I had no idea existed until earlier this year, and found some really cool use cases that I thought I'd like to share here. First, I want to talk about what the problem that server-sent events is trying to solve, and WebSockets and all the alternatives. Some of these may look familiar. These were not real Jira tickets or anything like that. But it can, at least for me, almost everywhere I've worked, people want real-time updates of things that are happening in the system. WebSockets have typically been the way to do that. So let's talk about what are some other ways that people solve the problem today. Polling. How many of you use polling? I use polling. Polling is the easiest way to do this because you can just refetch the API, refetch the data. This is kind of a simple example of how that might work. You call set_interval, and on every, 5 seconds, you refetch the data, re-render the data. This does add some unnecessary load onto your server, though, because now you're fetching data even if you don't need it. Another way, you may have heard of long polling. For a long time, I didn't know the difference between long polling and polling. So long polling is sort of like actually what we're going to be talking today about server-sent events and polling. But the idea is you make an API request, but rather than it responding right away, it holds on to the request until there is new data. So you make the request, and it keeps the HTTP request open. And then on the server, it says, oh, new data, sends the data, or the request ends, and then it makes another request. So that's this recursion happening here. So it calls long poll again, give me data for the next time something happens. WebSockets. So this is actually pretty easy to implement. All of these things are available in the browser, unless you need to support some older browsers. Very efficient, low overhead, and then allows the client to use the same connection to send data as well as receive data. So this is really good for like your real-time data apps, the Google Docs type collaboration tools. The tricky part here is that you do have to handle the reconnection logic. WebSockets, if they disconnect, you have to reconnect. That's why you usually end up using a library to handle that kind of thing. This is a rudimentary way of reconnecting of when we close the connection, reconnect. The other thing is that the server has to be able to support WebSockets. It has to upgrade the HTTP connection. The handshake logic for WebSockets can be a little bit involved. You usually need a library for that kind of thing. And we'll look at an example here of implementing WebSockets on the server and some of the problems I've run into with WebSockets. So it's an example of a simple server. There's some auth middleware, and there's going to be a handful of other middleware things that are going to set up things on your request to set up your context for what's happening, make sure that the people who are hitting the API are authenticated, that sort of thing. Now with the WebSocket server, when we pass in the server into this constructor, This is handling all of the upgrade, on upgrade, does the whole handshake with WebSockets. So that takes care of all the complexity for you. But what this doesn't handle is all of this middleware. Because when it upgrades the connection, it now breaks out of your middleware handling and is going to, you have to handle it yourself. So you have to be doing everything your middleware is doing to make sure that they only have access to the things they have access to, set up your database connections. You have to do that yourself, and is often missed. So on to the topic of this talk, server-sent events. So the server-sent events is a spec to use HTTP to get events from the server. So the one thing server-sent events doesn't have that WebSockets does is using the same connection to have the client send data. This is just the server sending new events, but it uses a single HTTP connection. This is the thing I did not know existed until earlier this year. This is something available in browsers today, not Internet Explorer, like most things. But this is all it is. You give it an endpoint, and it is going to make an HTTP call to that endpoint and listen for events. If it gets disconnected, this reconnects for you. So you don't have to handle any reconnection logic. This takes care of it for you. And if you are sending an ID, and we'll talk about the actual spec, if it gets disconnected and gets reconnected, it will send the last event ID that it got, so that you can, on the server, say, oh, they left off here, I can start at that point, so they don't miss out on any events. The other thing is that because it is just HTTP, it goes through all of your middleware. So little example here. So assume all the imports that we had in the previous example. So app.get stream. And our request handler, there's just a few headers that you need to know about. The content type is this text/event stream. That's telling it the format of the body is going to be this type. Keep alive because we want the connection to stay alive. And don't cache because these are going to be events that that are going to change over time. In this example, we're just doing every 1 second, we're going to write data : then whatever I want to send, and 2 new lines. And we'll talk about the format and all the different things. And then after the response closes, clear the interval so we don't keep the interval hanging. All right. There are some limitations to server-sent events. It doesn't replace WebSockets. It may replace it in some use cases. Because it does use HTTP, many browsers, when using HTTP 1.1, has a maximum of, I think, 6 HTTP requests that can be open for a given domain. HTTP 2 doesn't have the same limitation. So if you have some kind of Nginx proxy that's handling all the HTTP 2 stuff, or you're doing that yourself, you won't run into that limitation. But just something to be aware of. The data is only coming from the server. That being said, you can still send data via other API requests. You can send a post. You can do all those things, and then have the stream send you data from those events that happen. It is limited to UTF-8, which is still a huge number of strings that you can put in there, but just be aware of that. Not supported in IE11. However, there are polyfills. Because it's just a spec of how the HTTP response is sent, you could even do this on an XML HTTP request handler. So there are polyfills available. One thing that I came across recently was you can't send custom headers. All you do is you give it an endpoint. And I think in most browsers you can pass a custom last event ID. but you can't set the headers unless you're using the polyfill. And last I checked, I was looking at issues for the actual spec, and they were looking to, or people were wanting to add custom headers into the spec, but some of the Google developers said, yeah, that's not really on our radar right now. Most people just use fetch with the streaming response, and that's how the polyfills do it. But something to be aware of. All right, so here's some things that I've found good uses for server-sent events. This doesn't mean WebSockets can't be used for these things, but anything with simple notifications, someone's using your website and you want to pop up a notification saying, hey, your document was updated, or you have a new approval. A turn-based multiplayer game. In the process of preparing for this talk, I created one. A real-time data dashboard, so where it's just you want to update a dashboard with data, because you're not really adding new data when you're viewing the dashboard. A chat application, that's kind of iffy. It's probably more suited for WebSockets, especially if you want the so-and-so is typing type of things. But if you're just posting a message body and you want to see the messages, chat application would be fine. Event delivery, so if you have like an eventing system and you want to deliver those events to another system, or if a customer wants to pull data in, you could use it for that. Things they aren't good for. You've probably read most of these while I've been talking. Anything sort of real time, probably not great for, because for the client to send data, you need to go through the overhead of a new post. Whereas with WebSockets, that can be a lot quicker. Live document editing, there you really want to be able to see people's cursor placement and all that kind of stuff. And although you could have like a read-only view pull from server-sent events endpoint, that's if you want the collaboration, you really need WebSockets. Binary data, because UTF-8 is the only thing supported for server-sent events. WebSockets can support binary. Anything requiring a lot of simultaneous connections, that goes back to the limitation of the number of concurrent connections. All right, so here is what the server-sent events actually look like when you do a curl request to an endpoint that supports the spec. First, you get the headers. So those are the 3 headers I talked about. And then when you get an event, this is what an event looks like. All of these fields are optional. You don't need any of these, or you only need one, or whatever. That ID is what the browser uses to cache, all right, I've seen this event, and so if I get disconnected, I'm going to send this ID back to the server, if the server wants to do anything about it. You can customize the event type. This has to do with the message handler on the client. So you can have on update, on message, on whatever you want. Retry, this is telling the browser, hey, if you get disconnected, retry after this many seconds. The data can be whatever you want. It's just a string. In this example, I have a JSON object that would then have to be parsed on the client side. And then just this colon with text, that's a comment. That doesn't get parsed by the browser. That doesn't do anything. I've used this to keep the connection alive. Some cloud providers like Heroku will start disconnecting, or will disconnect any HTTP request that has gone on for 30 seconds without any data. So you could use this as kind of a keep alive thing. You just send a comment saying, keep this alive. And then when you want new events, you add 2 new lines, and you have a new event. And so this HTTP request just stays open and as new events come down. If you want to do a multi-line value in the data, you have to prefix each line with data, keep them sequential. Usually if you're just sending JSON, though, you don't need to split it into a new line. And like I said, not everything is required, so I don't have any of the retry things in there. So yeah, that's what it looks like. So let's take a look at an example. The code for this is located here. And after this, I'll be out in the lobby if you want to come chat with me. And this is, we won't go over this because I'm not wanting to be on the internet. It's a real-time, or not real-time, a turn-based game called Connect Force. It's like Connect 4, but you can rotate the board and all the pieces fall. That was fun. All right, so for the example, all right, so this is, I'm going to start here. This is just a one-file application to kind of demonstrate how this works. So this is just going to be a node server. Here's my index.html. I have a body with a single element, and here I create the new event source /stream, and I add the event listener message. So before, in here, when it says event update, that's what I would use to customize that. So if I wanted to listen to these events, I would add update in there. So on message, I'm going to create a p tag, and just whatever it is in data, that's what I'm going to add as the text content and add it to the root. And the actual server is just on get / it's going to send that index HTML up here. On get stream, it's going to do that res.writeHead, like we showed before in the example. And we have a list of listeners that we're going to keep track of. So we're going to set on this response, whenever we get new data, we're going to res.write that data with the 2 new lines. That's important. That's because that signifies I'm done with this event. And on any other request, what we're going to do is we're going to loop through all the listeners and send the request method and the request URL. So I'm going to do kind of a live exercise. Whew, sorry. Node simple.js. So the server started. I'm going to come over here, zoom in a little bit. Blank page, no events. I'm also going to pull up the dev tools here so you can kind of see. I'm going to refresh there. So there's the stream. And now I'm going to curl this localhost 3000 /hello. Get hello. If I change this to post, who are you? Get the events. And if you in Chrome, I couldn't find any tools in Firefox, but in Chrome, you actually get an event stream that parses all that data and gives you nice debugging tools to see what that actually looks like. All right, so a more advanced one, but similar, is this server sent events chat thing that I put together. So I'm going to start the server. Actually, I'm going to start it in dev mode so that you can see server restarts. You know, you don't have to worry about anything. But just going over the code real quick. So the index.html, actually, maybe we should just look localhost 3000. So here, we have a chat there at the bottom. We can enter in, hello, how are you? So that's this input form. And the JavaScript for this didn't require any libraries. So here, I get the messages, get the input form. When I submit, I pull off the text input. I call fetch with a post with the body, clear out the message. And then here's where I create the event source with credentials as sending cookies. So if you have cookies, you can somewhat control the headers. And then whenever we get a message, we render the message. And that's the thing that creates the element, adds the text content, and appends the message. On the server side, some of this is a little bit more fleshed out. So this is my messages service. This is just all in memory. The game that I linked to, that if you'd like to see more, the code is also on my GitHub profile. That actually uses a database to keep track of things. But this is just an array of messages. You can subscribe to the messages, and you can send messages. And this close will just clear out all of the handlers for all those things. And then on the express side of things, I have a router that when I get it, this library here, or this just code within the server. This takes care of all of the adding the headers, making sure that we clean up our responses when the responses close. And here, we call messages.subscribe. And here is also where we pass in the last event ID so that we can start where we left off if the request gets canceled or whatever. And this render event is taking these keys and essentially doing this. Those are the same thing if you wanted to just do it manually. No library required. Don't need anything fancy. Oh, and the server restarted, and everything looks to be OK. Yep, everything still works. The last thing, no, actually, I think that was it. It's not really a whole lot. It's a lot less complicated, I find, than WebSockets. The WebSockets definitely has its place for very simple things. This can answer a lot of those first problem solutions. I want to know when something changes in the system. I want to be notified. I want to know when something happens. And if you'd like to talk to me after, or I guess I should ask, do we have any questions? Yes? So it was said that it looks like a nice wrapper around long polling. Yes, very much so. It's a standard that has some nice tools around it. Or nice tools. It has nice built-in functions into the browser. That EventSource class built in. You don't need to npm install anything unless you want the polyfill or need the polyfill. Oh yeah, that was what I was going to show. This also would be possible with long polling. But if I want to curl, messages. Yeah. So there's the message that existed. And actually, why don't we get the headers on that? So we got the headers, all the content type, all that stuff. And if I type in another message here, is this long polling? Yeah, shows up there, right there. So it's easily debuggable because you can use curl. Can't do that with WebSockets. Though WebSockets has plenty of other tools to do this kind of thing too. Yeah. More questions? All right. Thank you.